All right, let's talk serverless. It's fast, it's powerful, but there's a trap. A really common one that a ton of developers, maybe even you, are falling into without even knowing it. And we're going to expose it today.
So picture this, right? You've got Margaret, a senior engineer, looking over the shoulder of her junior colleague, Timothy. And she just stops and asks this one question. It cuts right to the bone. It's about a huge, and I mean huge, security flaw that's hiding in plain sight in so many serverless apps.
So you have to ask, why would Timothy do this? And honestly, it makes sense at first glance. It's what a lot of us are taught to do. It feels, good enough for handling secrets. It's the standard way, right?
And if you ask Timothy, he'd have a pretty solid defense. He'd say, hey, look, the API key isn't in my source code. That's a big win. And he's right about that. Then he'd say, plus, AWS encrypts those environment variables at rest. So we're all good, right? Case closed? Not so fast. This is where Margaret just kind of shakes her head and points out the trap. See, what looks like a good, safe practice is actually a classic anti-pattern. And it comes with some seriously scary problems, both for security and just getting things done. So let's dig into what those are.
Okay, so Margaret's first point is super important. Think about it this way. Environment variables are for configuration, not credentials. What's the difference? Well, configuration is like telling your app the name of a database table or what log level to use. No big deal. Credentials? That's the password to the kingdom. The API keys, the database passwords, they just don't belong in the same place. And that's the whole ballgame right there.
So what are the real risks? Well, for starters, visibility. Anybody on your team with even basic read-only access to the AWS console can just see the secret, in plain text. Yikes. Then there's the friction. Need to change or rotate that key? Guess what? You're redeploying the entire function. What a pain. And that leads to the biggest problem, security incidents, because rotating keys manually is a nightmare. It's easy to forget, easy to mess up, and it's basically a ticking time bomb. Okay, so if environment variables are the villain here, who's the hero? Well, Margaret introduces the solution, a purpose-built digital vault. It's called AWS Secrets Manager. And trust me, this is a total game changer. So what is AWS Secrets Manager? It's pretty much exactly what the name says. It's a service from AWS that's built for one thing and one thing only, to securely store, encrypt, and lock down access to your secrets. Seriously, think of it like Fort Knox for your API keys.
And the best part? It's actually really easy to get started. It's just 3 steps. 1, you create a new secret. 2, you paste your API key or password into it. And 3, and this is the most important part, you create a super strict IAM policy that says this role can only read this one specific secret. Not all of them, just the one it needs. What you're doing here is following the principle of least privilege, which is a fancy way of saying you give things the absolute minimum permission they need to do their job. So now, a developer can work on the Lambda function all day long, change the code, update the config, but they can't see the secret it uses. The two things are totally separate. That's a huge security win. Okay, so Timothy's probably thinking what you're thinking right now. All right, this sounds great, but how does my code actually get the secret from the vault? Isn't calling an API on every single Lambda request going to be super slow and cost a fortune? And you know what? That is an excellent question. And yeah, let's just hit that concern head on. You're right. If your function gets hit 1,000 times a minute, you do not want to make 1,000 API calls to Secrets Manager. That would be a performance nightmare. But don't worry, there's a really clever, elegant pattern for this. The solution, my friends, is caching. Look at this. The very first time your Lambda runs, that's called a cold start. It makes one and only one API call to Secrets Manager. Yeah, it adds a few milliseconds. But after that, for every single other request that hits that warm container, 0 API calls, 0 added latency. It's basically free after that first hit. So how is this magic even possible? It's actually a simple coding trick. It's all about where you declare your variable. You see, when you declare your secret variable outside of your main Lambda handler function, the Lambda environment itself holds onto it. It fetches it once on that cold start and then just keeps it in memory, ready to be used over and over again instantly. So we've got security, check. We've got efficiency, check. But there is one more, killer feature that just seals the deal. This is the part that gets rid of so much manual work and late-night stress. 0. Look at that number. That's how many times you have to manually deploy your code just to rotate a key. Because Secrets Manager can do it for you, automatically. You can just set it and forget it.
Tell it to rotate the key every 30 days, and it just happens. No code changes, no deployments, nothing.
So let's just recap the big wins here. Your secrets are actually secure, locked down tight with IAM. Fetching them is super efficient thanks to that caching pattern. And maybe best of all, the whole painful process of rotating keys is automated, taking human error completely out of the equation.
And that really brings us back to the beginning. I want you to think about your own applications. I know you've got secrets in there. We all do. But the question is, after hearing all this, are they truly secret?